Hello.
Good evening, sir.
Evening. Do you have any doubt from last class to any of you?
No, sir.
What we did in last class? I think non-uniformly accelerated motion.
Yes.
Okay. I'm giving you one problem. Let's say if velocity of a body is try to solve this part. We have velocity which is equals to 3 times t square minus 2t. And we have to calculate acceleration and next displacement. So how you proceed it? In last class, I defined you acceleration is nothing but dv over dt if velocity is time dependent function. So in this part, we have given velocity as t dependent function. So just differentiate it, you will get acceleration. And now put the value of t to be 2 seconds, you will get acceleration at t is equal to 2 seconds. In the next part, we have to calculate displacement. So as we know, this velocity is nothing but dx over dt, and it is equals to 3 times t square minus of 2t. Now move this dt to the other side, you will get dx is equals to 3 times t square dt minus of 2t dt. Now if you have to calculate this dx, just integrate it, you will get displacement. Since there's no any function related to x here, so just put x raised to 0. Now simplify these two terms, you will get acceleration as well as displacement. Is it clear?
Yes, sir.
If Ikra, any doubt?
Sorry, sir. Could you repeat?
Which part? Both or displacement or acceleration? In this part, we have given velocity, which is 3t squared minus 2t. So you have to calculate first acceleration. In last class, I defined you how to calculate acceleration. So we would have two different formula. First, if velocity is time dependent function, just differentiate it with respect to time, you will get acceleration. And there is one more relation. If velocity is x dependent function, so acceleration would be equals to v dv by dx. Now in this problem we have velocity as t dependent function. So you have to differentiate it with respect to time to get acceleration. This is the first part. In next part, you have to calculate displacement. So how to calculate displacement using this velocity? As we know, velocity is nothing but dx over dt. So just put the value of v as dx over dt. Move this dt to the other side and just integrate this whole expression, you will get displacement. Is it clear now?
Yes, sir.
Okay, just try to solve. Just solve. I'm coming 1 minute. Good, Samara. Mariam. Without just send me your answer. Samira, just check your calculation. Let's say if you differentiate this velocity, you will get 3 as constant term, t square. So on differentiation, it will be 2t raised to 2 minus 1, minus 2 as coefficient, having exponential of t as 1, so it will be 1t raised to 1 minus 1. So on solving, you will get 60 minus 2. Now put the value of time to be 2 seconds. You will get a is equals to 6 into 2 minus 2. So 6 into 2 is 12, minus 2 is 10 meter per second square. Is it clear?
Yes, sir.
Yes, sir.
Okay. Similarly, if you integrate this particular part, x raised to 0, so it will be 0 plus 1 divided by 0 plus 1, t raised to 2, so it will be 2 plus 1 divided by 2 plus 1, minus 2, t raised to 1, so it will be 1 plus 1 divided by 1 plus 1. So on simplifying, you'll get x is equals to 3 times t cube over 3, 2 times t square over 2. This 2 and this 2 will cancel out, this 3 and this 3 will cancel out. Now, if you put t to be 2 seconds and simplify it, you will get x is equals to 2 cube minus 2 square. 2 cube is 8 and 2 square is 4, so it will be 8 minus 4, that is 400. Is it clear? Samara?
Yes, sir.
Okay.
Done, sir.
Okay.
Done, sir.
Now, on the basis of this calculus method or non-uniformly accelerated method, you have to define or prove equation of motion. So, equation of motion using calculus method. So first is v is equals to u plus at, or this particular equation is also termed as velocity time relation. So how to approach this part? Let's say velocity and time will give you acceleration. So let's say acceleration is dv over dt. Now rearrange this equation. You will get dv is equals to a times dt. Now just integrate this whole part. On putting the limit, let's say at t is equals to 0, object would have initial velocity at u, and at some later time t, it will have velocity v. So you may write this equation as v raised to 0 dv, starting from u to final velocity v, which is equals to a to be constant, integration t raised to 0 dt from t is equals to 0 to t. Now on applying equation related to this integration, it will be 0 plus 1 divided by 0 plus 1. Limit v to u is equals to a t raised to 0 plus 1 divided by 0 plus 1. Limit t to 0. Now if you simplify it, you will get v upper limit lower limit is equals to a t upper limit lower limit. Now if you put the value of v as upper limit and lower limit as u, and there will be negative sign in between, a upper limit as t, lower limit as 0, and on simplifying you will get v is equals to u plus at. Is it clear?
Yes, sir.
Yes, sir.
Write it down.
Done, sir. Done, sir.
Done, sir.
Sabita, done? Next equation is S is equals to ut plus half at square. So this particular relation is termed as displacement time relation. So as we know, displacement and time define you velocity. So let's say velocity is equals to dx over dt. So just rearrange this, you will get dx is equals to v times dt. In this expression, there is no any component of v. So just replace this v using first equation of motion. You will get u plus at times dt is equals to dx. Now break this, you will get dx is equals to u times of dt plus at dt. Now integrate this. And next is to define limit. Let's say at t is equals to 0, displacement of body would be 0. And similarly, at some later time t, displacement would be s. So on putting these values in this expression, you will get x raised to 0 dx, integration from 0 to s, u t raised to 0 dt, integration from 0 to t, plus at raised to 1 dt, integration from 0 to t. Now, if you integrate this, you will get 0 plus 1 divided by 0 plus 1, limit s to 0, t raised to 0, so it will be 0 plus 1 divided by 0 plus 1, limit t to 0, a t raised to 1, so on integration it will be 1 plus 1 divided by 1 plus 1, limit t to 0. So this expression on solving will become x limit s to 0, u into t limit t to 0, plus a over 2 t squared limit t to 0. Now if you put the limit, it will be s minus 0, u times t minus 0, plus a by 2 as coefficient. If we put the value of t to be upper limit, so it will be t squared, and lower limit as 0 squared. So on solving, you will get s is equals to ut plus half a t squared. Is it clear?
Yes, sir.
Okay, let's write it down.
Done, sir.
Done, sir.
Done, sir.
So wait a 1 minute. Done, sir.
Now, third equation is v square is equals to u square plus 2 times of a into s. This term is, this equation is called as velocity displacement relation. So how to relate it? There is no direct way to define between those two terms. So let's say acceleration is dx over dt. There is no any component in this part containing time, so we have to remove this particular term. So just multiply this equation and divide this equation by same term. So it will be dx over dx. Now, if we rearrange this equation, just 1 minute. Acceleration is dv by dt, so it will be dv dv. Now, if we rearrange these two terms, it will be dx over dt times dv over dx. Dx is over dt is nothing but velocity, so it will be v times dv over dx as acceleration. So this is a relation to define acceleration when velocity is x-dependent function, which I have used in this part. Okay. Now, just rearrange this equation. You will get v dv is equals to a dx. Now integrate this. Let's say limit for this particular integration at x is equals to 0 or initial instant, velocity of body would be u, and at some x is equals to s, velocity of body becomes v. Now on putting these limit in this equation, you will get v dv integration limit from u to v is equals to a times dx integration limit from 0 to s. And if you are very much habituated about this particular dx, on integration, this particular term, it will give you x only. And how we get this x? I have defined you in so much problem, like in this part. dv on integration will give you just v. Similarly, in this equation, dx on integration will give you x. So just remember this, dx on integration will give you x only. Now, if you integrate this part, which having exponential as 1, so it will be 1 over 1 limit upper lower a, integration of dx would be x, limit s to 0. So this will become v squared. Now, if you put upper limit, so it will be v squared. Put the lower limit, it will be u squared, and there will be a negative sign in between. Divide by 2 is equals to a times upper lower limit. Now, if you move this 2 to the other side, you will get v square u square is equals to 2 times of s. Move u to the other side, it will be v square is equals to u square plus 2 times of s as your final answer. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Done, sir.
Done, sir.
Sabita, done?
Done, sir.
Okay. Ikra?
Yes, sir. Just writing the last part. Done, sir.
Okay. So this is all about non-uniformly accelerated motion, which can be solved using calculus method. Now, the next and very important part of this chapter is to define graph. Graph is nothing but variation of one coordinate with respect to the other, or representation of variation of one quantity with respect to another. So in this graph, we mainly define you two different parts. First is called slope. You'd say if you have a line whose coordinate will be x1, y1 and x2, y2. Now, if you draw vertical line, horizontal line, so this particular point will be termed as x1, this will be x2, similarly this will be y1 and this will be y2. So the difference of these two coordinates from this point to this point, it will be termed as x2 minus x1. Similarly, this particular length from this point to this point will be termed as
Y2 minus Y1.
y2 minus y1. Now, if you want to calculate slope of this particular line, which will be also called as m, or it will be tan theta, it will be equals to perpendicular by base.
X2 minus X1.
Now, if you have two coordinates and you have to define equation of line on the basis of this, just remember, equation of line is y minus y1 is equals to slope, that is y2 minus y1 over x2 minus x1 whole multiplied by x minus x1. But this particular equation is only based for straight line. How will this particular term would change for any curved line? Let's say if you have a curve from this point to this point. So using calculus, if you differentiate this particular function, it will define you slope at that particular given instant. And dy by dx is simply defined you tangent to this particular curve at this given instant. Similarly, if you draw a tangent to this particular point, it will define you slope at this instant. So whenever you have to calculate slope, just draw a tangent to this given point. Similarly, tangent to this given point, on the basis of which you will define slope or inclination of curve at this given instant or at this given instant. So for any curve, dy dx, which will be equals to tan theta, and this particular term will define tangent to the curve at this given instant. Is it clear to you all?
Yes, sir.
Just write it down.
Done, sir.
Done, sir. Done, sir.
Now immediately define first slope and second area related to any given curve. Suppose if you have any curve shape like this, whether it will be a circle, ellipse, or any term, how to calculate area of this particular ellipse? So just draw a coordinate from this point and the other from this point. Let's say this particular term is x1, x2. Similarly, draw a horizontal line. So it will be termed as y1 by 2. So whenever you have any curved figure, whether it would be a circle, ellipse, or any term, so its area will be equals to pi r1 into r2, where r1 will be along x-axis, so it will be x2 minus x1 over 2, and similarly r2 would be equals to y2 minus y1 over 2. Is it clear?
Yes, sir.
Next is suppose this particular figure is termed as ellipse, trapezium. So it will have x1, x2 coordinate at this point. This particular coordinate will be y1 and this coordinate will be y2. So the total length of this point to this point will be y1. Total length of this point to this point will be y2. And the difference of these two terms from this point to this point is x2 minus x1. So area of trapezium is equals to half sum of parallel sides into their separation. So in this part, parallel sides are y1 and y2, and their perpendicular separation is x2 minus x1. Is it clear?
Yes, sir.
Yes, sir.
Okay, just write it down.
Done, sir.
Done, sir.
Done, sir.
Subhita, done?
Sir, 1 minute. Done, sir.
Aisha, is it clear till this part?
Yes, sir.
Now I'm defining you some basic property related to any curve so that you confident about how this particular curve would look like. First, if y is equals to any constant term, so it will be a line parallel to opposite axis, that will be x-axis, and passing through that particular given constant. So it will be a line parallel to x-axis and passing through that constant. I'm giving you one example. Suppose if y is equals to 2, so it will be a line parallel to x-axis and it will pass through 2 like this. Is it clear?
Yes, sir.
Next, if y proportional to x, so it will be termed as linear or straight line. So the general formula of any straight line is y is equals to mx plus c. In this part, m is called slope or inclination with respect to x-axis. So it will be slope or tan theta, where theta is inclination with respect to positive x-axis in anti-clockwise direction. And c is termed as cut on y-axis. Cut on y-axis. Let me give you one example related to this. Suppose if you have a line joining between these 2 points. So this is the x-axis and y-axis. So first of all, you have to calculate inclination or slope, which is nothing but inclination with respect to positive x-axis to this particular line. So it will be at this point. So the inclination will be this. Is it acute angle or obtuse angle?
Obtuse angle.
So for obtuse angle, tan theta would be negative. So you will say slope will be negative. Next, C. C is defining you nothing but cut on y-axis. So it will be at this point. Just see, this particular point is above origin. So this would be positive. Is it clear?
Yes, sir.
So on the basis of sine of M and sine of C, you will easily define in which direction this particular line would move. Now there is one limitation in this. If C is equals to 0, so there will be no cut on y-axis, or you will say there will be cut on y-axis at origin. So it will pass through origin. Just write it down.
Done, sir.
Done, sir.
Done, sir. Done, sir.
Now next is y proportional to x square. Just remember, even power of x will be symmetrical curve along y-axis. So it will be symmetry along y-axis and vice versa. So this particular graph will define you parabola. So what do you mean by parabola? Since y is proportional to x square, so there will be symmetry along y-axis. So it will be termed as this graph. Is it clear?
Yes, sir.
Now, if there is even power on both coordinate, let's say x square and y square both, so we'll have x square over a squared, y square over b square is equals to 1, or if a is equals to b is equals to r, so it will be x square y square is equals to r. This particular term or equation is for ellipse. Or from the above statement, you will say even of power of x, it will be symmetrical curve along y-axis. And similarly, even power of y, it will be symmetrical curve along x-axis. So this will be a ellipse. And if a and b are equal, it will cut on both axes at the same instant. So it will be termed as circle. So this is your ellipse. This is your circle. And last, if y proportional to x raised to n, where n is greater than 1. So if you draw curve related to this, it will be rectangular hyperbola along this side. So this is termed as rectangular hyperbola. Is it clear?
Yes, sir.
Just write it down. I'm defining some basic equation.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Suppose I'm defining you for free falling body. Let's say if a ball is at this point and if it is allowed to fall freely on surface, on hitting the surface, it will get rebounded back to some lesser height and then it will return to earth and so on. So on the basis of this, if we define equation, first using second equation of motion, S is equals to ut plus half at squared. So just see this particular term to the highest power of t. So it will be t squared. So you will say S is proportional to t squared. So what would be the nature of graph? Whether it would be straight line, circle, ellipse, or any other term. So just compare using this. If one of the coordinate having even power, it will be symmetrical graph to the opposite coordinate, or it will be termed as parabolic curve. Is it clear?
Sir, could you repeat once again?
In this part, we have S proportional to t squared. Here we have even power to t. So whenever there is even power on one coordinate, the graph will be symmetrical to the opposite coordinate, or it will be termed as parabolic curve. Is it clear?
Yes, sir.
So graph of this particular expression would be parabola. In which coordinate? Towards displacement or towards height. Similarly, if you differentiate this function, or just take ds over dt, which is displacement over time, so it will give you velocity, which is equals to u to be constant, differentiation of 2, t would be 1, half a as constant, and differentiation of t square, it will be 2t. So on simplifying, you will get p is equals to u plus at. Now in this expression, v is directly proportional to t, or you may write this equation as v is equals to a times t plus u. Is it similar to y is equals to mx plus c? So this will be termed as y, this is x, this term will define you slope, and this term will define you intercept on y-axis. Is it clear?
Yes, sir.
Yes, sir.
Now, if you draw graph related to this, it will be a straight line. Since at this point, initial velocity of body is 0. So u will be 0. And it is going along downward direction in which gravity would be negative. So slope would be negative. And you will get velocity as negative. So if we draw, so it will be like this. Now on hitting the ground, its direction gets reversed. So velocity will become positive. So on going upward to the highest point, velocity becomes 0. So it will look like this term. And similarly, if you draw further, it will be like this, and so on. Now I'm defining you why this particular curve keep on decreasing, decreasing. This is your y coordinate, and this is your x coordinate. Let's say at this particular highest point, initial velocity of body would be 0. So you will get v is equals to minus of g into t plus 0. Since there is no any constant term, so it will pass through origin, which having slope as negative g, so it will be towards negative side. Is it clear?
Yes, sir.
Sir, can you repeat?
In this part, to fall free, so its initial velocity is 0, and it is going along downward direction, or gravity is always taken as negative for whole motion the gravity problem. So it will be minus g times t plus 0. Since in this equation there is no any constant term, so using this, if constant term is 0, it will always pass through origin. So in this equation as well, we have 0 constant term, so it will pass through origin, and having negative slope, so it must incline with respect to x-axis along negative side. Now, initially it is at this point, on hitting the ground, some of its velocity or energy would be lost in heat, sound, or other form, due to which its velocity from this amount of length would decrease to this amount of length. But on hitting, its direction get reversed. So initially it was along negative side. On hitting, it will be in positive side. Is it clear?
Yes, sir.
Yes, sir.
Okay, just write it down.
Done, sir.
Now, if you further differentiate it, you'll get A, which is nothing but G, which is in negative always. So it will be A. So A is equals to minus G. Whether this acceleration is time dependent or not. Mariam?
Yes.
Is this acceleration is time dependent?
Yes.
It means the acceleration of this particular A would change from time to time. It means at t is equals to 1 second, it will be 10 meter per second square or 9.8. At t is equals to 2 seconds, it will be 19.6 or 20 meter per second square, or it will be remain same. Acceleration to gravity is always constant. Okay.
Yes, sir.
So you will say A is equals to constant minus G. I defined you at this point by the constant. It will be a line parallel to opposite axis and passing through that given constant term. Is it clear?
Yes,
Similarly,
sir.
A is a constant term, so it must be passing parallel to the opposite axis and from that given coordinate. So it will be like this. Is it clear?
Yes, sir.
Samara, any doubt?
No, sir.
So this is all about this particular graph. I'm defining you some concept, how to calculate speed, velocity, distance, displacement, and so on. Are you all done till this part?
Yes, sir.
Yes, sir.
Yes, sir.
First is slope. Slope is nothing but ratio of perpendicular base. So first, distance and time. So its slope will define speed, displacement versus time. It will define you velocity, speed versus time, or velocity versus time. These two terms will define you acceleration. Now, next is called area under it. So acceleration versus time will define you velocity. But if you take mod of it, it will be next velocity versus time. It will be displacement. But if you take mod of it, speed versus time, these two terms will define you distance. Modulus means you have to take only positive values. Whether it will be negative or positive, you have to take all the terms to be in positive. Is it clear?
Yes, sir.
We just write it down. I'm giving you some problem related to this.
Done, sir.
Done, sir.
Done, sir.
Try to solve.
So the second question, distance Is it displacement?
Okay, just 1 minute. It should be distance and displacement.
Okay.
For this entire path. So it will be third question. First, you have to calculate acceleration between AB and BC. Second, you have to calculate distance and displacement for the entire path. And third is average velocity and average speed. Average velocity is net displacement over time taken. And average speed is total distance over total time. Should I give some hint? In this part, you have to calculate acceleration. So first of all, what do you mean by acceleration on the basis of displacement time graph? So just relate this. Slope of velocity time graph will define your acceleration. So you have to find slope of line AB. To get slope of any straight line, first take point of each part. So it will be 2, 4. Similarly, it will be 4, 4. Now, acceleration of path AB would be equals to y2 minus y1 over x2 minus x1. Just put all the values in this part, you will get acceleration. Ikra, you have done wrong.
Okay, sir. I understood.
Similarly, try to find for B to C. It will be y2 minus y1 over x2 minus x1. Ikra, just check your calculation. First part is correct, second part is wrong. Mariam, just send your answer. Samantha. Just see how to solve it. On going from A to B, B will be at final point, so it will be y2 x2, and A will be initial point, so it will be x1 y. So y2 from this will be 4, and y1 from this will be also 4. Divide by x2, 4, x1, 2. So 4 minus 4 would be 0. Divide by 2, so it would be 0 meter per second square. For the first part. Is it clear? Similarly, if you put all the values in second part, from B to C, so C would be at final and B would be initial. Good. So it will be 0 minus 4 divided by 5 minus 4. So it will be minus of 4 meter per second squared. Sabita, is it clear?
Yes, sir.
The next part is to define distance and displacement. Using velocity time graph, if we calculate area, it will define your displacement. And if you calculate area or modulus of area, it will define your distance. So just calculate area under the graph. Suppose to calculate area from OABC, which is defining nothing but trapezium. So area OABC will be equals to half sum of parallel sides. So it will be this point to this point, which is 5, and this point, which is 2. So it will be 2 plus 5. And perpendicular separation between them, that will be 4. 7 into 2, it will be 14 meter. Similarly, area of triangle, which is C to D, half by. So base is 1 and height is -4. So we calculate it to be -2 meter. Distance is nothing but mod of this area. It means whether it will be positive or negative, you have to take the only positive part. So it will be 14 plus 2. So it will be 16 meter. And for displacement, it will be as it is. So it will be 14 minus 2 as 12 meter. So the distance traveled by the body will be 16 meter and displacement will be 12 meter. Now, if we put all these values in this expression, average velocity is net displacement, which is 12 over total time, which is 6. So it will be 2 meter per second. Average speed is total distance, which is 16. Total time is 6. So it will be 8 by 3 or it will be 2.67 meter per second. Is it clear to you all till this part?
Yes, sir.
Sabita, any doubt?
No, sir.
You can just write it down.
None, sir.
Done, sir.
So this is all about this particular chapter